Dear colleagues, we bring to your attention research on the topic modeling the process of ensuring environmental sustainability of the airport as a functional component of socio-technical systems. The airports are vital hubs for global connectivity, but their operations significantly impact the environment through noise pollution, air emissions, and resource consumption. Rebuilding water airports in Ukraine presents a unique opportunity to integrate environmental sustainability from the ground up. This research adopts a socio-technical systems approach, recognizing the interplay between social factors and technical aspects to achieve environmental goals. A rebuilding of airports in Ukraine can face the following potential challenges. Implementing new technologies may require significant upfront investments. Public-private partnerships and government incentives can help overcome these hurdles. Integrating innovative solutions into existing infrastructure can be challenging. A phased approach and life cycle assessments can help optimize this process. Shifting organizational culture and personnel behavior towards sustainability requires training and ongoing support. Our work is motivated by the potential environmental, economic benefits and enhancement of Ukraine's international reputation. For instance, reducing emissions and pollution contributes to cleaner air and a healthier environment for communities surrounding airports. Sustainable practices can lead to cost savings through reduced energy consumption and improved resource management. Embracing sustainability aligns with global aviation trends and strengthens Ukraine's position as a forward-thinking nation. However, with the expansion of the world economy and the volume of air transportation, the issue of low environmental safety of the airport increasingly acute, and the need for a balanced development of all its links in lack of investments is revealed. Thus, scientists, governments, and businesses face the task of defining and systematically implementing effective mechanisms for determining the necessary level of investments for creating environmental safety of airports. Thus, the purpose of the work is to develop the conceptual foundations for ensuring the environmental sustainability of the airport as a functional component of socio-technical systems and the mechanisms for determining costs aimed at ensuring the activity of a society's unit in a specific spatial sector of the airport's architecture and spatial framework, taking into account the existing norms of environmental safety. To achieve the purpose set, the following tasks were formulated. The first, analysis of the impact of airports on the basic sectors of the economy of Ukraine, with the disclosure of their general characteristics in order to assess their state, using the example of total emissions of carbon dioxide and nitrogen oxides forming the ecological footprint of the airport's activity. The second, substantiating the basic priorities for the formation of an environmentally safe space at the airport as vectors that determine ways to improve its functionality as a component of socio-technical system. And the third, development of a mathematical model for determining the necessary level of cost aimed at ensuring the activity of society's unit in a specific spatial sector of the architectural and spatial framework of the airport itself. Airports are a vital component of the modern transportation system and the economy of any country, facilitating rapid and efficient movement of goods and passengers over long distances, contributing to the development of tourism, trade, business, and investments. The analysis of the impact of airports on the country's economy shows that airports provide access to international markets fostering business development and investment in the country. Airports ensure a fast and reliable mode of transportation. Airports contribute to the growth of tourist traffic. The development of airports facilitates the creation of new jobs. An airport as a socio-technical system combines a complex of technical, technological, economic, social, and environmental components aimed at ensuring the efficient and safe operation of passenger and cargo aviation services. As you can see, this system includes airport infrastructure, aviation technologies, airport personnel, financial and economic aspects of airport operation, as well as a system for assessing and reducing the negative impact of air transport on environment, including emissions reduction and resource optimization. The environmentally safe space is an environment where special attention is given to measures for preserving and improving ecological safety. Ensuring the environmentally safe space within the airport is of great importance. The priorities for the formation of an ecologically safe space at the airport are protection of people's health, environmental protection, nature conservation, and biodiversity, as well as ensuring sustainable development and social corporate responsibility. The development of environmentally safe space model for airports is based on a mathematical model of the societal unit's activity in a specific sector of the ecological framework architecture of the airport itself. This slide represents change in the environmentally safe space indicator over time in a two-dimensional system by the level of environmentally safe space potential as a component of the ecological framework architecture. The principle of determining the state of the geographical plane from the wind direction is proposed as the basis for the thematic determination of the level of environmental safety of the studied airport territory, which depends on the level of resources or investments. This principle allows monitoring the research object at any time according to a wide range of indicators that characterize the external environment. In our case, this is a state of health of a person from the amount of expenses necessary to maintain or restore his or her health, which has been affected by negative factors. It should be noted that a significant impact on the ratio plays the time factor, which is characterized by various social aspects of life like pandemic, war, economic crisis. This slide represents environmentally safe space model in a three-dimensional coordinate system. The volume of a parallelepiped formed by a corresponding three vectors determines the result, compliance with normative requirements for the qualitative indicators of a person's environmentally safe space. Unfortunately, in real life, there are many more of the factors which requires a transition to a 4- and 5-dimensional systems that can be done using linear programming. The research results can be applied to post-war reconstruction of Ukraine, airports, legacy airport transformation, and transport policy development. The presented model can guide the rebuilding of Ukrainian airports, creating environmentally friendly infrastructure from the outset. The model can also be adapted to existing airports, driving sustainable upgrades and operational changes. The findings can inform policy decisions at the national and regional levels, promoting environmentally responsible airport practices throughout Ukraine. Thank you for your attention.